Alright guys, welcome to our channel Code with Sunny. In this video, I will be talking about the easy problem reverse linked list and indexes 206. Okay, so in this problem we have to simply reverse a linked list. That's why it is a very easy type problem. You can do this iteratively or recursively. I will discuss both of the approaches in this video. Okay, so before moving on, let's look over the similar question section. You can see a reverse linked list second. It is a good problem. So after you are done with this problem, like this is a easy one, you can do this medium type problem. And if you are stuck with that, you can look out my video which is present on the channel. I think reverse linked list second. Let's see. Yes, reverse linked list second. It is like premiered on June 23, and there are more similar videos you can find that is reverse nodes in K group. That is also a good problem, and it is categorized as hard problem the LeetCode. And similarly, I think palindrome linked list is also one of them. Palindrome linked list, I think. Yes, this is also an easy problem, so you can also try with that to brush up your skills. Okay, so moving on to discuss this problem, let's try to analyze how it is going to be done. Like iteratively and recursively, we are going to reverse the linked list. Okay, so you can see that this is our actual linked list, and when we reverse this linked list, this is our new linked list where the head is going to be now pointed by this end node. Okay, so there are few of the things that you need to keep in the mind while reversing a linked list. I'm talking about the iterative approach first. Let me write down iterative. Okay, now you can see that the last node that is present over here is 5 now becomes the head of the linked list. Okay, so what we are going to do is we are going to do the like a simple iteration starting from the head of the linked list and moving on in one step to the next node and in the next step to the next node and so on until we reach the end of the linked list. Now just focus over these two like nodes. You can see that in our answered linked list, that is the reverse linked list, what are the position of the arrows for these two nodes? You can see initially one is from 1, there is an arrow starting from 1 and it is going up to the true. Okay, from 1 to 2. Now in this case you can see that from 2 to 1. It means that first we need to ensure that we need to reverse this arrow, right? So what we are going to do is let's start our few of the variables that we need to we need to require to solve this problem. Like let's say current variable at this position, and for reversing a linked list we need to also have the previous node address. So let's call this as previous. Note that previous is initialized as null. Okay, because there are no nodes that are for the like if this is the head node, there is no previous node for this one. That's why I initialize with null. Now, okay, now you need to reverse this okay. So first, you need to be very much careful that there is no arrow from previous to the current node. Okay, so what you are going to do, you are going to start your iteration from current and while it will goes up to till current not becomes the null. So your iteration will be like while current not equal to null. Okay, and each time you are going to increment your current to the next node. Okay, so you can notice that current is initially initialized to the head of this linked list, and in the next step current will be at this position, and in the next step current will be at this position, and so on until it reaches the end of the linked list, that is the null pointer. Now at the very first step of the like you can say at the very first step of this iteration, what you are going to do is like you are going to reverse this arrow. Like there is no arrow from previous to current, but you can see that in the final answered linked list, or you can say the reverse linked list, there is an arrow. You can see that from 1 to the null pointer. Okay, there is an arrow from 1 to the null pointer. So you need to ensure that you need to provide the null pointer right now when you reverse this linked list. So what you are going to do, you are going to assign current next equal to this previous value every time. Like when suppose that you are at this position, let's call this current at this position. In this case your previous will be at this position, right? And when your previous is at this position, you need to ensure that this arrow is going to be reversed. So what you are going to do is you are going to assign current next will be previous every time, but you need to be very much careful about the fact that if you assign currents next equal to previous at every step of your iteration, there is one problem that is going to arise. What about the next node? How you are going to iterate for the next node? If you assign current next as previous, you can see that this arrow will be lost, that you cannot go to the node 3 right now. In that case, you need to store the next node previously. Like at every step of your iteration, let's call it as next underscore node, will store the next node of the current step of iteration, that is the currents next. If I am being able to store this current next node, it means that if I will assign this current next as previous, that is reversing the arrow, then also I can move to the next node since we have already stored this one. Okay, so in this case you can see initially 1 is going to be pointed towards the 2, and here is current and here is previous. In the current step, what I will say, I will assign currents next as previous. So it means that 1 will remain here as it is and the arrow will be pointed towards this one. And we have already stored currents next, that is we have already stored this 3. Okay, so this 3 is already being stored. Okay, and you can also assign the previous variable or previous node will change every time. So current will move to the next node and previous will come up to for this node. So my previous will be at this position and current will be the position of the node equal to 3. And this goes on until we have until we have reversed all the arrows. Okay, so the code is like very much simple, like 3, 4, 5 lines. I don't remember. Let's move on to the coding part. I have submitted both, I think, recursive as well as iterative. So I will first look out for the iterative one. You can see I have assigned current as head, previous should be assigned as null, and there is a next node that is going to store the next node at every step of iteration. The next node will be assigned as currents next, and currents next will be assigned as previous. We have reversing the arrows, and previous will be moved one step forward, and similarly current will be assigned as the next node to move over the linked list to reverse all the arrows. Okay, that's why I've used this next node to store the next node of the current node. That's where without storing that we cannot move further to the linked list to reverse the rest of the remaining arrows. And finally return the previous. Why we have returned the previous? Because if our iteration ends, our previous will be at this position, right? And current will be at this null position. And you can see this is our new head. Okay, so that's why we have returned previous. This is the iterative version of this reversing a linked list. So let's talk about the recursive version also. This is also simple. So let's try to analyze. You can see the runtime of both the codes are similar, 8ms. Now what we have done is over here is we have assigned the new head globally as null, and this reverse head function is called, and each time we are going to recursively reverse the corresponding arrows going from the current node. Okay. Now what in the base case, if current reaches the null, we are going to return the current variable which is null as it is, and if it is not, let's call the node which is coming from the next node as I'm calling the currents next function. Okay, so it means that if let me just demonstrate with the help of this one. Suppose we are at this position. Okay, and suppose that in the current step what happens is this is current node, and you can see that this, when I've called this currents next function, the remaining list would be of this one. That is, we are going to discard this one and we are going to work upon this one. And in the next step, again we are going to work upon this one, and so on. So at every step of recursion, our actual linked list size is going to be reduced by one. Initially we have this linked list, and in the next step would be having this linked list. In the next step we would be having this linked list. Okay, and if we reaches the base case, you can see we are going to return the null as it is. Now consider this case we have only this node. Okay, now what will happen is we are also going to make a new node, that is this one, which is going to assign with the current value. Okay, and consider the case when node is null, it means that the value that is coming from here is null, and so it means that this is the our new head. That's why we are going to having reverse this entire linked list. So this will be our new head when this null comes from the next step of the recursion. So you can see I'm assigning new head as here right now. And what about this like node is not equal to null? Consider the recursive step at this position. So it means that the node that is coming from here will be like this one 3, and it is going over here as 2. Okay. So this is the now node, and this is the node that is coming from the next step of the recursion, and this is not equal to null. It means that the current node should not be the head node, and then in that case I will assign nodes next as now. That is, this is node and its next will be as now. Okay, and now's next will be null, that will be assigned temporarily. Okay, that's what I have done over here, and finally return the now, because our next current working node is of this one. Okay, so this will reverse the entire linked list. Okay, so if you have any doubts, do let me know in the comment section of the video, and I will ask the viewers to like this video, share this video, and to subscribe to YouTube channel for latest updates. Thank you for watching this video.